Oat milk is a type of plant milk derived from whole oat Avena spp grains by extracting the plant material with water. Oat milk has a creamy texture and a characteristically oatmeal-like flavor, though it is sold commercially in various varieties flavors such as sweetened, unsweetened, vanilla, and chocolate. Unlike other plant milks, with origins dating back to as early as the 13th century, oat milk is a modern creation, developed by the Swedish scientist Rickard Öste in the early 1990s. Oat milk may be consumed to replace dairy milk in vegan diets, or in cases of medical conditions where dairy is incompatible, such as lactose intolerance or an allergy to cow's milk. In the United States, oat milk is also manufactured into a non-dairy frozen dessert. Discovery. Soy milk predates all other alternative milks, including oat milk, both as a cultural and commercial product. Since the early 20th century, soy milk made its way from Asia to European and American grocery stores, initially as a dairy substitute due to lactose intolerance. The increase in consumption of soy milk since its global distribution created a large market for plant-based, non-dairy milks like oat milk. The first example of an oat-based plant beverage was in the early 1990s, when Rickard Öste developed oat milk. Öste was working as a food scientist at Lund University in Lund, Sweden, researching lactose intolerance and sustainable food systems, when he invented the drink. Soon after, Öste founded Oatly, the first commercial manufacturer of oat milk. Market expansion. The pioneer in commercial oat milk, Oatly, had its products in 7,000 coffee shops and grocery stores, as of 2019, but was not the only prominent oat milk producer. Oat milk can be found under brand names Oatly Sweden, Pure Harvest Australia, Alpro UK, BioAvena Italy, Simply Finland, Vitasoy Hong Kong, and Pacific USA, among others. In 2018, global sales of plant milks, including oat milk, were $1.6 billion United States dollars, with a forecast of $41 billion by 2025. In 2018, there were numerous oat milk shortages from unprecedented demand in Europe and North America, highlighting the strong consumer demand for this product. To meet the American demand, Oatly opened a new factory in New Jersey in April 2019, producing 750,000 U.S. gallons (2,800,000 L, 620,000 imp gal) per month of oat milk base, and announced plans for a Utah-based factory 3 times larger to open in early 2020. In 2019, retail sales of oat milk in the United States were $29 million, up from $4.4 million in 2017. An oat milk frozen dessert is sold in the United States. Process. As of 2019, Oatly obtained oats exclusively from Canada to supply its factory in New Jersey. The production of oat milk is similar to that of most other plant milks. Cereal grains like oats are indigestible when unprocessed due to their hard, outer hull, so processing is necessary to create a product suitable for manufacturing as a liquid. The procedure starts by measuring and milling the oat grains to break apart their outer hull, then the grains are stirred in warm water and ground into a slurry. The slurry is treated with enzymes and heat to create a thick liquid oat base. In the United States, Oatly ships the treated oat base liquid to a subcontractor for processing into the final oat milk product. Soaking and subsequently extracting nutrients from the oats have the most direct implications on the final milk product. Increasing the yield in this step may be assisted by chemical catalysts, enzymes, or an increase in temperature, all in order to remove nutrient molecules from the solid byproduct and incorporate them into the liquid. Chemical catalysts increase the pH of the mixture, enzymatic catalysts induce partial hydrolysis of proteins and polysaccharides, and higher temperatures increase reaction rates. Separating the liquid from the solid byproduct is a simple step achieved through filtration, decanting, or centrifugation. Once the liquid product is isolated, adding other ingredients, such as fortifying vitamins and minerals, or sweeteners, flavorings, salts, oils, and similar, formulates the final product. Oat milk is naturally lower in calcium, iron, and vitamin A than dairy milk, so the addition of these nutrients is necessary in order for the product to be a direct nutritional substitute of dairy milk. Homogenization and heat treatments such as pasteurization or ultra-high temperature (UHT) treatments are used to extend the product's shelf life. Challenges to processing. Because oat milk is produced by the disintegration of plant materials, the resulting particle sizes are not as uniform as bovine milk. This variation in particle size is due to the vastly different lipid and protein molecules. Decreasing particle size, improving particle solubility, and using hydrocolloids and emulsifiers are common ways to improve product quality via homogenization. Another problem posed by the natural composition of oats is their high starch content. The starch content 50 to 60% is challenging during UHT treatments because of starch's relatively low gelatinization temperature. To overcome this, producers use an enzymatic hydrolysis of starch by alpha and beta amylase, producing maltodextrins which gelatinize at higher, more suitable temperatures. Adding ingredients as fortifying nutrients is also a difficult procedure. The nutrients must be bioavailable and stable in the final product, otherwise the quality or effectiveness of the product may be insufficient. Research is often funded to discover procedures which successfully incorporate bioavailable nutrients into oat and other plant-based milks. Uses. Oat milk is used as a substitute for dairy milk in custom coffee preparation and in fermented dairy products, such as yogurt and kefir. Baristas claim that oat milk needs less steam than cow milk, froths favorably, is tasteful, rich, and creamy like cow milk, and effectively balances the acidity of espresso coffee. Along with other non-dairy milks, oat milk may be used as a substitute for dairy milks when cooking or baking.